This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's show, we're going to talk a little bit about the Vineyard Wind Project, just approved here in the U.S. We're going to chat about drainage hole cleaning and some of the lightning implications for drainage holes and the water that can be potentially kind of reservoir up inside of a blade. We'll talk about kite power, which is something, obviously it's wind energy, just of a different type. And we'll also talk a little bit about some new blade recycling tech just announced by Vestas. So, Alan, let's start with the Vineyard Wind Project. So obviously this was a big thing with the Biden administration, and this got approved pretty quick, and it's going to bring a lot of offshore wind power to your neck of the woods.
Yeah, and off the coast of Massachusetts and New York and all the eastern seaboard states, there's just if you've ever been out there, it's kind of windy, especially you get offshore a little bit. There's like constant wind. So it has been talked about for years, at least 10 years now, about having some wind turbines offshore off the coast of Massachusetts because the winds are just good and stable. And it's finally happening. There's been a lot of resistance in the state about it, particularly from fishermen, from people who own land along the ocean. Have been complaining about it for a long time. So to see it at least start is a good sign, but until it's in, I kind of wonder if it's really going to happen. So it has a long way to go, I think, before we get through all the little tiny details about the site and what's going to happen and what's going to be installed and how it's going to be installed and what effect it has on the local economies, and all those things haven't been settled yet. So there's still details to go through, but it's a good start. It is a good start.
Well, potentially up to 4,000 megawatts of capacity, and the 800 megawatt Vineyard Wind Project is going to be a piece of that. But it's a lot of wind power coming to the U.S. It'll be interesting to see how fast that comes together. And like you said, some of the industrial changes that are going to have to happen in factories and all these jobs that are going to have to come to fruition there up in the Northeast.
There's going to be a ton of new jobs and training going on, and it's going to create its own local economy. It's essentially what it'll do. But very little of that infrastructure is there right now. So it's all created from the ground up. And then that's going to be the hard part. All the details are going to be the hard part.
Yeah, and of course, there's probably, like you said, there's probably going to be more challenges to it. I don't know. I mean, now that it's proved, I don't know how far they can go, but I'm sure that's not the end of some of these high-powered residents up, in the Nantucket area. There's a lot of money up there. So
yes, there is.
Yeah, and there's obviously with Martha's Vineyard, and I think people will probably have some worries, again, like the very high wealth residents of these areas, that it's going to maybe bring people they might deem undesirable to their area, or like more blue-collar workers into this very closed-door, white picket fence kind of area. And that's... I think that's a disappointing attitude, and I think that's why a lot of these projects get fought, for their beloved view into the Atlantic Ocean, right?
Sure. Well, you pay a lot of money for it, and you want to maintain that value that you had, and if it takes away from future buyers, that's a problem. It decreases the value, especially in such a fine sliver of the housing market and the land market. You're playing at these really volatile ends of the market, and little changes like that can increase or decrease value. So, people are rightly concerned about it. But as time goes on, the stress level has come down a good bit. I don't think you'll see such huge fights about it like we were 10 years ago, but there'll still be fights. It's inevitable.
Well, and one of the things I had been hearing or reading, just various articles from different perspectives, just that already there's fights like in New York State about how much, of the materials and of the machines themselves should be shipped in from overseas. Like, shouldn't we be manufacturing them all here in the U.S.? Is that realistic? Like, and one of the things that was cited is that even in the UK, where there's obviously a ton of offshore wind, it still doesn't make sense in all situations. And in fact, in a lot of situations, to throw up a factory even right there. Like, it still makes financial sense to ship them in from China or from somewhere else, depending on just the complexity and the size and the cost and just the overall scope of the program. So that'll be another interesting battle, because everyone's like, well, all right, well, we're doing this here in the U.S. Like, why aren't we doing all of it here in the U.S.? But sometimes, just like, with a company, sometimes it just makes sense to bring in a contractor, bring in a consultant, rather than train all of your people and get all the systems. Just like, let's bring in someone who's already got this up and running if we're going to try to get this out the door on time. I mean, you see that with the aircraft sector, right?
Oh, sure. Sure you do.
I mean, Boeing, you think like Boeing or Airbus, like one of these huge aircraft companies, just make every part of the plane, right? Like, that seems like an outsider's perspective. Like, why don't they make their own engines? They're paying $20 million for an engine. Like, why don't they make their own? But it's just so expensive to get the plants and the factories and the workers and the expertise.
The people. Yeah, that's the problem. And Massachusetts is in a little bit of a weird spot in this sense. The government pretty much runs on the more liberal side, Democrat side, which usually comes along with support of union jobs. Those two have been interlaced for a long time. Like when they had the big dig, when they basically restructured all the roads in the center of Boston, that was roughly $1 billion event. And there was a lot of interest that connected into that politically to get their part of that pie. And I don't see the wind turbine effort being really any different. I think it's going to play out in a similar way. There's going to be a lot of, in Massachusetts, backroom deals that you're not going to hear about. But when there's such a large pile of money on the table and politicians have some way of influencing where that goes, they will. Obviously will. That's where the fight starts, is that the common citizen is fighting against their own state government, which is what's going to happen. And we saw that in the Big Dig, we saw that in other things with roads in Massachusetts and numerous other large projects in the state. I just don't think this is being any different. You prepare, it gets to be just commonplace. You can almost check the boxes. Okay, there's going to be this lawsuit, then it's going to go away, and then the unions are going to ask for their share of the pie, and they're going to get it, and the chain just rolls on. It's just what's going to happen.
So yeah, I mean, we'll keep our ear to the ground with that, and then there's going to be so many developments with those projects over a long period of time. But they are putting in the GE Halley 8X, which I'm excited about because it's got the best name in huge offshore wind turbines.
Well, there you go.
They are American. Yeah, it's an American company. So
where's GE's headquarters at? And I think
that's a good question.
I think they were going to move to Boston at one point. I don't remember if they actually did. I remember at one point they had bought a lot of land right down on the water to move their headquarters to Boston. So it's not surprising that has happened, right? You've already got sort of GE clawing their way into that. It's in their territory. So yeah, sure. But yeah, that's the way those things go, All
right, so let's move on here to drainage holes. So, these things have to be cleaned. Just part of the regular maintenance of these wind turbines, and they can fill, the blade tips can fill with water. And over at Arones, they've got some interesting technology with their robots helping to clean those out. But Alan, what's the big deal with drainage holes? I mean, is it a big lightning risk? That's the angle I want to kind of chat with us today. Is it that big of a deal if your drainage hole if you got a little water inside? Does it really need to be cleaned that regularly? I mean, is this going to increase the likelihood of lightning damage and severe strikes?
It can. And the general thought about it is if you have water trapped in the tip area of the blade and there's a lightning strike, that water is going to evaporate and then create all this internal pressure and then cause the blade to split. Now, in theory, I guess that's possible. I haven't seen that in any sort of laboratory testing played out, but I'll tell you what the water does do, which I know is a problem, which is it causes a bunch of corrosion. So anytime you have corrosion between electrical joints, it just creates arcing and sparking and bad stuff to happen. So the water starts to eat away at metal components like the lightning receptor and all the cables and things that are inside, and that just leads to a degraded lightning protection system. So when Arones goes out and starts measuring these lightning protection systems and they find high resistance values, that's one of the reasons why, is that there's just a corrosion issue and there's water trapped in there is just eating away at the metal components. That's the first one. The second one is, I think it's the water, when it's trapped like that, starts to weep places, and if it happened to freeze, then you got a really big problem. But it tends to weep into the structure, and so the structure just sort of absorbs it, and it's not as dielectrically strong. It's not the ability for lightning to puncture through it is less than if it was dry, and that's a problem. So you don't want water trapped in the blade very long. You want it to drain out, and what Arones is finding is that they start cleaning out these drain holes is that they're getting liters, gallons of water to pour out of these blades pretty regularly. I've heard stories of technicians, guys on ropes that are cleaning out these drain holes. They said, well, there's 30, 40 gallons of water in there. Like, wow, 30, 40 gallons is a lot of water and stress, in my opinion. It's heavy. It's heavy, you're right. And you're slinging this thing around at some pretty high speeds. So it can't do good things to the blade structure. And you need to make sure those holes are clean because, as we've seen in many cases, if the blades are stopped for any length of time, insects are going to be right up in those holes. And like in Texas and other places where there's all kinds of great hornets that like to make nests and bees that like to make nests up in these holes, it's just a continual problem. And at least Arones is addressing it in a logical sense in this manner, which is I don't have to have a technician on a rope to clean those out anymore. I can do it with basically a robot system and do a lot of them fairly quickly, which is the beauty of Danus's and Arones' approach, is the quickness of it. And because you can do it so quick, you can cover a lot of territory, which means you can come back in a year or two and do the same thing again because it's so inexpensive to do. And that's the bonus. And I think so a lot of the measurements that Arones is making for lightning protection system resistances will start to clear up as they get the water out of the blade.
So moving on, I want to chat a little bit about Vestas. So they've made a big announcement this week. Unfortunately, a little bit vague. I was hoping to get a little bit of a deeper dive into what they're actually doing, but Vestas has announced a partnership with Olin, which is like a chemicals company. They specialize in like resins and resin systems, stuff like that, to break down old blades and recycle them essentially into what they're saying is virgin materials. Again, not exactly clear what that means, but I have two questions for you here. Number one, you know a lot about composites, having worked in aerospace for a couple decades. Is it easy to take these apart? Obviously, chemical producer Olin has a specialty in resins, right? But it doesn't seem like this has been done before, and now they feel like they found a way. And my second question to you is, if Vestas is invested in this, is this something that's going to be available to everyone else? Like, is this going to be proprietary, kept close to the vest? Pun intended, Vestas.
That's great question.
This is something you want the whole industry to be able to do, right? Because you don't want to only be able to recycle Vestas blades, but all blades. So I'm curious how that would play out in the future.
I wonder if there's a licensing play that Olin's going to be involved with. I don't know, because it is a dramatic statement to say you're going to take a thermoset, and what they're saying is they're basically pulling the thermoset resin out of an existing blade or a future blade that they can break that down, get the fiber out, and reconstitute those chemicals that made that epoxy or that hardening system, thermoset, happen. So a thermoset is a chemical reaction that occurs to basically take two chemicals and make them into liquid chemicals into a hard, stable, durable solid. So there's a chemical reaction that happens, and you put fiber inside of that to tighten it up and make it very, very strong, right? So to undo that chemical reaction and to get back to base components again is hard to do. There's no details, and I was thumbing through patents too to see if I could see an application or something. It's got to be somewhere where the magic lies, and I haven't seen it yet. So it must be pretty close to the vest at this point. But you're right, Dan. I mean, if it's such a game changer in terms of reuse, recycle, it would be a shame if that technology doesn't transfer out to the GEs and to the Siemens Gametas and all the other companies that are making wind turbines, because it's not just needed in one manufacturer. That's a worldwide solution to a problem that needs to occur. So we'll have to see. Yeah.
And of course, I'm not assuming that it won't be, right? There just hasn't been any word about it. And of course, if you're one of these big wind turbine producers and you can make a partnership like this and you can find a solution, sure, you jump on it. So there's no reason to assume that Vestas wouldn't, share this or license it or whatever. But obviously, it makes good sense for them to jump on it. So, that's just a question on whether or not this would be a ubiquitous technology where everyone can use in the future, if it even, if it makes sense to do that. Because it might take tons and tons of factory and labor to get this done, where it's not going to make sense to, I don't know.
Economics may not be there.
Yeah, to stand this whole project up might take a lot, where only they're really poised to do it once they get it going. You never know. Yeah. But yeah, a lot of turbine blades coming online, so they got to go somewhere, and they're gigantic. We all know this. I still vote for some sort of mechanical creature, like a King Kong kind of thing, to just smash them. Then we can create a huge arena and just watch them just snap them like chopsticks. That's my vote personally. They can just stomp them into submission, but I digress. Last on the agenda today, let's talk about kite energy. So if you haven't seen these, it's really interesting. It looks like the leader in this division right now is SkySails, and they have sort of what looks like a parachute and attached to a cable, and it's essentially just loops around the sky and drives a turbine back on the ground. Not like a wind turbine, but it's got its own. Again, the details of it they do a decent job explaining, but it's not exactly clear to me how that's converted into electricity. But it's essentially a way to harvest some energy from pretty high up on up to 400 meters up in the sky. So SkySails is one company that's doing this. KiteMill is another one. They don't have a parachute design. Theirs looks more like an actual physical glider, like a hard, again, if you just imagine a glider. Yeah. And then there's a now defunct company called Makani. And they were, I think, doing this about 10, 12, 13 years ago, and Google invested in them, but later dropped their investment. So, Alan, I mean, what are your initial thoughts about some of the stuff that SkySails and KiteMill are trying to do, harvesting these higher swirling winds?
Well, the SkySails is interesting because it's essentially a parachute that's on a cable that's tied to a generator. So as the wind pulls the parachute system and the airfoil further away, it's spinning a generator. So they're using that wind to basically tug a line. It's spinning a generator. So the kicker is that then when it gets out to its full extension, they basically change the air shape of the airfoil and they bring it back down. They're not using a lot of energy to recoil that spool of cable. That's sort of how it works. So it seems like they were going to pair them up in ones or twos or threes of these things. And it seems simplistic enough to work. As crazy as it is, it seems like it's going to work, and they've got working systems put together, which is really cool. So I'm interested in, as it gets out into service. It's supposed to be Q1, and we're past Q1, but it's got to be out in service relatively shortly. I want to see this thing out in service. I want to see it working, because I think that the idea is really interesting. If it works, it's even better. And how well it works in a variety of environmental conditions is going to be key. So it's something to watch. It really is.
Yeah, well, and there's some interesting videos we'll link below, as we always do. But you can attach one of these parachutes to not a cruise ship, but just like a freighter out in the middle of the ocean. And it can be swirling around and generating electricity for that ship, which is a really interesting concept. So yeah, I mean, one of those, early technologies, although again, like the idea has been around for over a decade, and the Google leaders, Sergey Brin and Larry Page, were pretty interested in it. And it looks like after they stepped out of Google, stepped down from their major positions, that then the project kind of was sent down, and other leadership, I guess, maybe didn't see the merit. I'm not really sure why that dissolved, but yeah.
There's a lot of projects like that. That's not the only one that happened to. And there was several aerospace type programs that were going on simultaneously. I remember a number of those getting the same sort of outcome when leadership change happened. So that's not uncommon. I do think though that the more you can prove it out in real service, that's where all the details are, and you show that it works, then you see a wide variety of customers start to come to your door. It's the proving it out part is the hard part.
Well, and obviously, and they talk about this as some of the issues are that, with weather, I mean, it's a huge thunderstorm, like they got to bring it in essentially.
Sure.
And so forecasting, like not every storm can be predicted 10, 12 hours ahead of time where you can just like pull them all in. Sometimes it's pretty unexpected, especially in some of these tougher environments. So, like you said, getting it out in the field will be crucial for them to figure out, hey, how fast can we bring this in, and how can we avoid damage to it, and how does this whole thing work over a given period of years where you're going to have lots and lots of different weather conditions that could affect the kite. So, well, that's going to do it for today's episode of the Uptime Podcast. Be sure to tune in next week. We've got a great guest on the show, and we'll explore some new technology here in the wind energy market. As always, follow us on YouTube, iTunes, Spotify, and check out the links in the description below for all the articles we mentioned in today's podcast. And we will see you here next week on the Uptime Wind Energy Podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.